For this video, we're going to look at a few shortcuts to taking derivatives. So one of the first shortcuts is, instead of doing the definition of the derivative, what if you just have a function y equals c? So it's some constant. Well, if I were to graph that, let's say that c is a positive number. It truly doesn't matter. Then my graph would be a horizontal line. And we know that the derivative represents the slope of the line at any point. Well, the slope of this line is 0. That's going to be true for any constant we graph, whether it's positive, negative, or 0. So our first rule is, if you take the derivative, and let's say we're doing it with respect to x, of some constant, you will get 0. Now it's important to note that it's 0 when it's sitting off by itself. Like the constant is, let's say it's x squared plus 3. Then the derivative of 3 is 0, but if it was 3x squared that you're looking at, this 3 is multiplied in and you would not say that the derivative is 0. So that's our second rule. We have the constant multiple rule. So let's say you take the derivative, and we'll do it with respect to x again, of some constant times some other f of x. Well, that's going to be equal to the constant times f prime of x. It does not turn it into 0 and wipe it out, so you'll just take this number and multiply it by whatever the derivative of your function was. So for this one right here, we would take our constant 3 and multiply it times the derivative of x squared, which happens to be 2x, and then that would equal 6x. The third rule is the power rule, and this is one of the more powerful ones. So let's say that you're taking the derivative with respect to x of x to the n, where n is a rational number. So by a rational number, it can be a positive number, it can be a negative number, it can be an integer, whole numbers, or it can be something that can be written as a fraction. So x to the 1/2, x to the negative 5/3, anything like that, but a rational number. Then the shortcut to taking the derivative is, we would say that we're going to take this n and we're going to multiply it down in front. So it would be n times x, and then we're going to drop this power by 1, just n minus 1. So that's like what I said right here. I said the derivative of x squared was 2x. Let's split this up. So this is 3 times x squared. Well, the 3 is going to stay with it, and then I'm going to figure out what the derivative of x squared is. So I'm going to take my 2, multiply it down, and then I'm going to subtract 1. So this is 3 times 2 is 6, x, then 2 minus 1 is to the first, so the derivative of 3x squared equals 6x. And that's the power rule in action. The last rule that we look at is the sum and difference rules. So let's say that you're taking the derivative again with respect to x, and you've got something with multiple terms. So we'll just say one term, we'll call it f of x all by itself, another term g of x. If you take the derivative of this, you don't have to look at it in its entirety. You can look term by term. So this would equal f prime of x plus g prime of x. In other words, if I took the derivative of x squared plus 3, I can just take the derivative of x squared, which we just looked at was 2x, and the derivative of 3, which is a constant, so plus 0, and the derivative equals 2x. And those are some of the basic rules that we're going to start with.